working. Oh, the audio is working. Here we go. Check, check, check. Welcome back, physics fans. Here we go. Question number 11. A rock is thrown up from the top of a cliff at 8 meters per second. How long does it take before it hits the ground 120 meters below? So that's a really tall cliff, and you're throwing it up at 8 meters per second. It reaches the top of its flight, and it comes back all the way down and hits the ground. Okay? So we want to look at it, it would be nice to look at it as one big step. This is the launch point A, and this is the landing point B, and we'll ignore what's doing at the top. We can do that because we have the initial speed is 8 meters per second, and it's up. The displacement is 120 meters down, and the acceleration is, gotcha, I'll fix that, is 9.8 meters per second squared down. So these are the givens. The VI is up 8, D is down 120, and A is down at 9.8. Now we can just go right from there to get time, and that means we don't have final velocity and we don't need it. So we're going to solve for time. This gets me a little worried. Okay, why? Well, we're going to use this formula. Let's just do it right here. D equals VIT plus 1/2 AT squared. D is 120. VI is 8. I'm making a mistake, yes, on purpose. Just see if you can figure it out. 1/2, and then 9.8, and T squared. My mistake is I didn't worry about direction. Okay? Because I have arrows, and the arrows are there to shade direction, and if they're in opposite direction, then they have to be an opposite sign. So if I make this negative, then this has to be positive. If I make this positive, then this has to be negative. They're in opposite directions, so in the formulas, they have to be in opposite. Which one do I choose? Does it really matter? It doesn't matter. Okay? I, unfortunately, for most of you, choose acceleration is always positive. That's where the change is. It's going towards that. So I always do that, positive. So then I always do it that way. But that makes up positive, and all those people that do math and think that this is the positive direction, I do that as a negative. Okay, so that's why some people hate me for doing that, but we get the same answer. So I'm going to do 120 is positive, therefore this is negative. And this is just t, and this is t squared. So just writing down the numbers again and putting it all to one side, we get 0 is equal to 4.9 t squared minus 8t, and then I bring the 120 over here, it becomes minus 120. That is a quadratic. We have to solve it for t, so I'm going to use a quadratic equation. So there's the term of 4.9 in the front, and that's our A term. And the negative 8 is our B term, and our C term is negative 120. So the formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So it's negative B, which is going to be 8, positive 8, plus or minus the square root of 8 squared, or actually negative 8 squared, but anything squared becomes positive, so it didn't really matter. But just semantics, let's just put a negative 8 squared, minus 4 times A, which is 4.9 times 120. Okay? But this 120 is negative, and it better be, because then we can solve this discriminant. Let me just get rid of the square root. Let's see if I can get rid of that square root button for a second, and then put the negative in here, and change it to black, and draw my square root back in here. Because if that was a negative, and making that a negative, I could definitely tell that would be a much bigger term, and I wouldn't want to subtract a negative and get a negative in the denominator, in the square root. All over 2 times A. A is 4.9 2 times 4.9. So I get 8 plus or minus, and then the square root. I'm going to start putting this into the calculator. Okay, so 8 squared plus 4 times 4.9 times 120. So underneath the square root is 2416, and that's all over 9.8. So the square root of that number is 49.1528. Okay, so I'm going to go abnormally to the left here, and I'll get 8 plus 49, right, and there's my decimal, 49.15 divided by 9.8, and my other answer would be 8 minus 49.15 all over 9.8. This is going to be a negative time, and it can't land before I throw it, so this term is going to disappear. Okay, and so I'll add 8 to this number that's on the screen, times it, add it to 8, and then divide it by 9.8, and I get a time of 5.832, I'll keep it 4 sig figs, seconds. Okay, and I'm just going to use big red lettering. There's my givens, and that's where I started. That's the quadratic way. Now I'm going to solve it a different way. I'm going to solve it, even though we're asked to solve for time, I'm going to solve for velocity, the impact velocity first. Even though we're not having to calculate it, what happens if I don't want to do the quadratic way? I don't want to use this formula to solve for t. Then I solve for the other one, VF. So I use the VF squared is equal to the VI squared plus 2AD, no time in it. Okay, so I get VF squared is equal to VI squared. VI is negative 8 squared plus 2 times 9.8 times, and downwards is positive 120. So this is 8 squared plus 2 times 9.8 times 120, and I get 2416. So VF is going to equal the square root of that. You might be seeing something, don't say anything yet. 49.15 meters per second down is the impact speed. And then now we want to find the time. And the time is just going to be the change in velocity divided by the acceleration. That just comes from the formula acceleration is the change in velocity over time. And I just rearrange it to that. The change in velocity, well, it's going down at 49.15 minus the initial, which was a negative 8, all over 9.8. So basically I have to add 8 to this number, and when I add 8 to that number, plus 8 is 57, and then I divide by 9.8, I get the same number, 5.832 seconds. Okay, that's good. There's another way to do it. want to see another way, or is that good enough? Beg your pardon? That's good? Okay.